So my name is Peter Jones. As you see, I come from Cisco, and I'm going to talk about Ethernet in general. So there is a small update. I just actually got a promotion come through last week, so now I have lost my principles, and I'm now distinguished. So you can figure out what distinguished means. But it was a big deal for me, so I want to make that point. So I work within the Catalyst development team for Cisco. So anyone here got Cat 3850 running in their networks? Anyone? Okay. That's what I spent my life doing to start with. So I joined Cisco 2005. Mid-2006, I started working on 3850. 3650 is now the most successful switch out there. And that heritage has gone through to Cat 9K. So I also do a bunch of work in industry bodies, CHI-NOG, MBST Alliance. The things I care about is evolving infrastructure and making stuff that's consumable. So when I first came to Silicon Valley from Australia, I found lots of people who wanted to build like very cool things, the castle in the sky, I'd call it. And they didn't really care if it ever got adopted. But that's not me. I actually want to build stuff that everyone gets to adopt. And so when I showed up at Cisco and I worked on the Cat 3K, that proved the right place to be. All right. So I'm a stand groper, which means a person from Western Australia. We've got any Texans in the room? Anyone from Texas? Okay. Western Australia is 4 times the size of Texas. So don't tell me about your big state. Okay. I'm going to talk in general about Ethernet. I'm going to go pretty fast. And I understand that there's a slight crypto problem here because I'm partly encrypted for you guys. I'm going to try and give you like a swag across a whole bunch of topics, and we'll try and figure out what's useful. Like I'm going to be around all day, so if you want to follow up, come and see me. And Jason, I don't know if you want to figure out a way to do this. Like I have like an hour and a half version of this. Maybe we can do this as a podcast, a webcast later on. All right, actually I need to go back. Also, advertisement, the best presenter in the world, because it works on multiple screens at once, it works on WebEx, and it works on LCDs. This is actually the original picture that Metcalfe drew. You know, he's got the cable ether in here. This was the telecom ether, and then there was the radio ether. So that's the Ethernet memo in '73. So this picture, which people are more familiar with, this was actually drawn for slides. And so basically it was drawn 76. And this is what people think about it. Who in the room remembers like the fat yellow coax? Weren't vampire taps a whole lot of fun? I actually spent more time on CHI-NOG, and I like CHI-NOG better because you could just extend it yourself. And then of course you'd be absolutely fine and the guy on the other side of the building would be totally toast. So Ethernet is older than a lot of people in this room. So who was born in '73? It's a pretty small subset. Then Ethernet is older than the rest of you. So the Ethernet memo was at Xerox PARC in '73. The patents filed '75. The first standard is '83. By the way, do you guys know, Ethernet is IEEE 802.3. Do you know what the 802 is for? The 802 is because it was 1980 in February as they started that project. All right, Twisted Pair. Twisted Pair is where I live because I'm on campus. All right, I found this on a Cisco site. I really like this. It's a variation, of course, of House of Cards because House of Cables. Because in reality, if you think about how you build most infrastructure on the enterprise side, without Twisted Pair, there would be no connections. So we've sold about 4+ billion, 100 base, 1,000 base T in the last 20 years. It's about $1 billion a year. Why has base T succeeded? Got a couple of reasons down here, right? Ease of use with structured cabling, incremental speed upgrades, you don't have to change it all at once, and get power and data on a single cable. To my mind, those are the key reasons that it succeeded. Right, so I work on 2.5 and 5G base T. I introduced a specified, I do the MBST Alliance. MBST Alliance was a vendor org to get 2.5 and 5G base T running. Like, why 2.5 and 5? All right, so between 2003 and 2014, we sold 70 billion meters of 5 and 6. 70 billion. So that would be about 10 meters each. So it's 90% of the installed base. 2013 and 14 it was about 1.3 billion outlets, and they're gaining at about 110 million a year. So from my point of view, this is an enormous infrastructure asset. Right? If you think about it, often cabling is like, it just has to work, right? We'll put it in cheap. But if you have to recable, like what's the expense? Imagine in this building, like I want to recable the building, I probably have to close it down. So we need to look at that cabling as an asset and we have to get more value out of it. Making sense? Awesome. Okay, I also did some work for the Ethernet Alliance. This is their 2018 roadmap. Ethernet Alliance is one of the vendor groups, and their job is basically to sit between 802.3, which is the standards group, and the rest of the community. Mostly it's actually vendors, doesn't have to be, a bunch of universities, and they do an Ethernet Alliance roadmap. So I actually have a few of these, which I'll give out sometime later, maybe at the social. And their job is to try and tell the story of Ethernet. Now, the cool thing about this is you can go get these graphics. You can download it from here. You can go get these graphics as high quality PowerPoints and use them in your presentations. They do put the nice little logo on the bottom. So if you think about it, right, these are all the areas of Ethernet running, right? There's the top end up here, all the way down. So I mostly live in, oops, I missed one. I live in this area, so I live in the campus. I also starting to live in the industrial space. And I'll get down to what I'm doing there later on. All right, so I'm going to talk some forecasts. Like one of the things that's nice for me is I get to talk to, as both working in 802.3 and also as an alliance chair, I get to talk to analysts about like what they think is coming. What's interesting is there's lots of information out there that doesn't get out to the community. Like why doesn't it get out? You have a day job, right? You have a day job. So often the vendors or the analysts, we think, because we say it a few times, right, everyone listens, and the reality is they don't, because you've got other things to do. Okay, this is copper cabling. So BISRIA is probably the premier research group for copper cabling in the world. They're actually based out of London. They're actually originally, I think, a non-profit of some sort. So this is global sales of copper cabling in outlets or drops, predicted out to 2012, 21. So people think that copper cabling is dying, right? Because there's access points and there's all the data center stuff. Gonna make the point. Oops, I lost, the animations don't come through. That's interesting. All right, here's the point. 5E and 6, if I go at 2021, is still the bulk of the market. And we're growing. So if you have the idea and your bosses say this category 5E stuff is going away, right, the answer is it's not true. That infrastructure is gonna hang around for an awful long time. All right, so what's it used for? So what's interesting is what we're seeing here. The number of pure data ports is going down, which makes sense. Right? Most people are now connecting to Wi-Fi. If I look in the Cisco building, almost everyone plugs in through Wi-Fi. I'm through Wi-Fi, but not. But there's lots of other things. You know, this is the access points, but this is the IoT section. Now, I have another slide in backup, which will tell you what's going in there, but the biggest number of growth is actually other. So what we're seeing is we're plugging everything else in. And if you think about the network, right, it used to be the fact that you would sell 2 ports per person, right, PC and a phone. Now it's maybe 1 port and none, but there's lots of other things getting connected. Does that jive with what you guys see? Okay, switch ports. I told you I hang out with some of the analysts. So this is from Deloro. Deloro are probably the premier vendor in terms of stuff. So again, looking out to 2021. Well, actually, if you go back in time, right, around 2006, it was mostly 100 meg. For quite a while now, we've been mostly gig. But if I go back to 2021, it's mostly still a gig. Okay, what's interesting about that? Next thing up here, this area here, this is growing, this is 2.5 and 5G base T. So this is like the biggest growth area. So this is what we're doing, is we're going and taking existing infrastructure and speeding it up to enable new services. Does that make sense? And sorry, your name, sir? Chris. Chris, okay, Chris, you're responding, so I get to talk to you, and maybe someone over here as well. What you actually see up here is there's some interesting things. 10 gig is actually shrinking. 40 gig is sort of disappearing. 25 and 100 are growing. But all the sexy stuff is up here, right? This is actually the money. So I work in the business of the money side of the house. I think of myself as making Camrys and Corollas. This is a Mac thing. I'm actually losing the animations. 1, 2, 3. Okay. Install base by speed. So this is from 650. 650 is a spin-off of Deloro. So the installed Ethernet switch base is 1.2 billion into 17. This is the section that's more than a gig. So, you know, if you read the news, there's I'm going 25, I'm going 50, I'm going 100, I'm going all these things. That's an awesome, exciting story. It's just not where most of the business is. Right, there's the move to wireless. When I started working on the project that became 802.3BZ or 2.5 and 5G base T, and I'm out talking to people, they were actually predicting that the crossover between Ethernet and .11 would be around about 2016. What's interesting now is they're guessing it's out to 2020, 21. I think there's a couple of things that changed this. I think the rise of IoT has changed it because there's now more things coming to the network. I think also they're finding that Wi-Fi is great, but there are places where it doesn't work so well. If you have someone who actually has to have high bandwidth available all the time, you really don't want them on Wi-Fi next to the microwave. Now, 11AX might fix that. So on this topic, same group, connections by type. So the change had happened pretty early from 11N to AC Wave 1. So this is sort of an interesting change, and I think it was partly driven by the fact that the vendors wanted to push the change, and it was valuable, so we priced it appropriately. So 11AC Wave 1 adoption, I think, was quite fast. So the change to Wave 2, according to his specs, is like now. I'm not sure I see that yet because I don't see that many 11AC Wave 2 clients, but I know it's going to be pretty fast. So the next thing coming over here is 11AX. So if you think about it, AC Wave 1, under reasonable conditions, you can get above a gig. Wave 2 with a couple of radios, you can get more than that, right? I could go with a whole discussion of macro, microcell, and stuff across, I'm not going to go there. 11AX, many people are familiar with it. Okay. AX is really designed to get high density. So their goal was 4 times the throughput per user in a busy environment. So AX would be great here. It would be great in a library, it would be great in a studio, sports arena, something like that. Whether AX is actually better for everyone, I don't know yet, but for high density, it's going to be awesome. All right, so we know where Wi-Fi is going. All right, so this is again from Deloro. I actually got a call because I was talking to the lady who runs this, is called Dan Deloro, and I was trying to get in some information because I speak at Cisco Live. So I was trying to get some stuff for Barcelona, and she called me up, I think it was December. I only picked up the call by accident. So she was in New Zealand, and she's very excited. She just finished a long-term report. It's like, awesome, what is it? So when I started this business, I was thinking that we're going to lose a lot of switch revenue to wireless. And actually, it turns out it's not going to happen. So these are numbers, and she released this report in January. So this is the revenue for Ethernet substituted by wireless LAN. And this is actually aggregating. So she's saying basically out in a couple of years, wireless LAN is actually adding to Ethernet switch revenue. I'll say that it's adding to. And so I think when I dived into this a little bit, while people are converting to wireless, we're actually expanding the network. So Wi-Fi is showing up in more places. So between the IoT stuff, there's fundamentally more network out there. Making sense? What you expected to see? All right, I'm going to talk a little bit about the Ethernet ecosystem. The thing is like, it's a bit like the European Union. There's a whole lot of people, right? They talk to each other sometimes well, sometimes not so well. And most people don't know who the other guys are. So, this formatting is really bad. Okay, Mac formatting. Right, sorry about the formatting, but here we go. So this is the core group is 802.3, right? 802.3 is the IEEE group that owns Ethernet, right? So they are responsible for the standard definition. So they've been going for an awful long time. And we actually do a project. So 802.3 was the first, then it was A, B, C, right? We're currently up to CH. We're doing a few projects. Around them, there's people like the OIF, the Optical Internet Working Forum. They tend to do research-y more things on high-speed optics and distance. Right? And so they provide information that gets adopted by other people. There's groups called, there's the cabling guys. So in America, that would be, in Europe, that would be ISO, IEC, JTC1, SE25 Working Group 3. That's the guys who own copper cablings in building Europe. Over in this part of the world, it's more like TIA, TR42. So these guys define how to put cable in and how to make it reliable. Right? And so without their work, right, we couldn't build Ethernet on top of it. So they're just another part of the ecosystem. There's a group called BIXI. Anyone know who BIXI are? Okay, so BIXI are the guys who define the standards and do the training for how to put cable in walls. So BIXI actually spun out of AT&T. So I go and talk at BIXI because I want to go and explain to people who put cables in the walls how I'm going to make their asset more valuable. Ethernet lights, I talked about that earlier. They basically look across all of Ethernet and they sit between the community and the standards groups. In-base lights, which I share, I'll go into more later on. So here's sort of the way I think about this, right? So there's from the customers in the field, I get information from you guys, and then I can go and present it into these groups. What that means is when I show up and speak, I don't speak with, I am Cisco, I speak with, across a very broad range of people, here's what I need. So the fact that I can basically aggregate from you guys and present into this lets me both do my job and lets me have power. Not power, leverage. So I can go in and say, here's what we need. And so most standards groups, they have a bunch of people who are very high tech, very smart, but they're not connected to the field. So you need to guide them in the path of righteousness. I also listen to what these guys are saying and then talk to you. So this is an example of that. Because as I said before, I've been telling a story about 2.5 and 5G based T for 4 years. I still run into people who've never heard of it. And I could just get frustrated, or I could just say, guys, you've got day jobs. So we have to keep providing information because we need to have it ready for you when you're ready to consume. Okay, what's .3 doing? That's the current list of the projects that are up and running today. I'm actually active in a couple of these. I'm actually active in mostly the Yang data model definitions. I'm also active in CG, which is 10 megabit single pair Ethernet. We're going to talk about this a little bit later. Previous projects included BQ, which was 25 and 40 GBSD, BG 2.5 and 5, and also 8.3cc, which is 25 gig single mode. Okay, so I'm going to talk a little bit about MBASD and MGig. So MBASD Alliance. So we were formed in 2014. We're a vendor alliance for 2.5 and 5 GBSD. We've got a boatload of stuff on our library. I'd encourage you to go take it, understand it, and then use it where you need to. Who's in the alliance? We have network infrastructure companies, components, systems, etc. And the alliance role is really, when we started off, we were forming up consensus for a standard. Anyone remember .11n? Okay. It took an awful long time because we actually locked in the standard. In the standard script I work in, you need 75% of the room, maybe a room this big, includes all your competitors, 75% of the room for a technical decision. So let's say you guys want one coding and you guys want the other one. You actually don't make any progress. So the real trick with a standards group is to go and find the value message that you can bring everyone along with you. You have to avoid the technical argument because let's say you want to send the mail via carrier pigeon and you want to send it via carrier ferret. Right? The customers don't actually care. And so it's easy in the standards group that people get confused and they start arguing technology instead of value. Does this make sense? So this is our current list of people that are in it. You know, the top end is the people who got started. You know, Quantia is a PHY company, Cisco, Intel, Marvell, etc. And then you go all the way down. What's getting interesting is the people down the bottom here, the adopters, they're getting broader and broader. And I'll talk about a couple of these products later on. Okay, what's the strength? We have a full ecosystem. Let's imagine I come out and I say, I've got this great idea, right? I have a switch in mind, an access point in mind. You can plug them together, they go faster. And you say, that's awesome. Can I plug in anyone else's? Like, no. Is there any test gear? No. Where's it come from? Okay, that's not a way to succeed. That's a way to demonstrate but not succeed. So we have the full ecosystem, and we got a standard done in less than 2 years. As I showed you earlier, it's also predicted to be the fastest growing market by 2021. And this is technology that did not exist in 2014. Okay, some application areas. We put this together as the Alliance because we had to talk about it. Anyone work for a university that has a hospital? Okay. So we're trying to figure out what you need in there, right? There's a whole lot of places that need more bandwidth. So I'm going to highlight this, and again, this is small, but you can pick this up later on. So you might need, switches, wireless access points, desktop storage, and small cell. Because these things all exist, right? You shuffle medical images around. You have people who do content editing. You have small cell. These are all places where you need more than a gig. Well, actually, where you can consume more than a gig, and then you can add value. But that's not the only place that exists. Let's think about the industrial side of the house. So if you think about industrial plant, you actually have similar things. So industrial plant, you've still got switches, you've got wireless access points, you've got storage, because you've got people out there doing CAD/CAM, you've got compute, machine vision, and then you have things like sensors. And so one of my favorite products is a small camera. It's a line scan camera from a company called EV something. So it sits about this big. It sits in the end of a conveyor belt. And what it does is as things fall off the conveyor belt, it scans them as they fall. Backhauls that to a machine vision computer, figures out whether it's in spec or not, and then decides whether it falls into the good bucket or the bad bucket. Okay, so that thing generates about 4 gigabits a second. If I can plug that in without rewiring my factory, I can fundamentally change how it works. Home, you're starting to see a bunch of people now offering product. Netgear's one of them, Buffalo's another one. There's cases inside the home where you really want more than a gig. Right? Let's say you've got a nice new NAS that can drive a bunch of stuff. Let's say you want to do streaming. Let's say you're just like a techie geek and you've got a whole bunch of stuff. Let's say you want to be doing big video copies. So there's already specific gaming products coming out of Netgear. Also, let's say you're moving forward and you want to drop off a more than a gig service in the home. I don't want to recable the home. If I look in the SP side of the house, again, you get small cell, home gateways, other things. So the point I'm trying to make is that 2.5 and 5 GBHT becomes valuable across the full industry. Okay, oh my God. Mac formatting questions. All right, so this looked really pretty on my other slides. All right, so I've got 3 questions. Like, who needs more than a gig? What are the roadblocks and what's the value? Got 3 answers. Digital transformation is here. So the edge of the network is fundamentally changing. It's changing with things like sensors that figure out where people are. It's changing with automatically controlled offices. It's changing with machine vision. It's changing with a lot of other things. So we have to enable that transformation to happen. You want to be in a case where you can help the business change, not prevent it. Okay, what's the biggest asset? Think of your building, right? If I came to you and said, look, I've got this great idea, it'll just make everything better, but you just have to close your building down for 3 months and recable it, that's not adoptable. So if you're thinking about that installed cabling asset, I have to figure out how to get more value out of it. And so my thing here is I want to basically say, I want to upgrade the network, not the building. Does that make sense? All right, I'm going to talk about a few use cases. I've got enterprise wireless from University of British Columbia. I got some scientific compute from Monash Pharmacology Department. I'm going to talk cruise ships. All right, anyone from university? Oh, it's a university up here. Good Wi-Fi is now table stakes. University of British Columbia, they have a huge wireless network, right? It's 5,000 APs, they have less than 6 SSIDs, and they have policy and VRF based on identity. There's a really interesting backstory to how this is built, and there's actually a case study you can go find on Cisco Live, but this is basically the network. So if you think about it, a few years ago, right, Wi-Fi was a thing that you provided and people loved you, but now on a university, if Wi-Fi is not there, everything's going to stop. And it's true for your guests, it's true for your students, it's true for everyone. So this is actually a picture of the University of British Columbia student section. You know, as you normally see. I'm going to point out some things. At this stage, this is a test. He's got 516 meg down, 370 up, and at that stage, he has 160 people on this SSID access point. Okay, this is what you're going to need to be able to provide. You've got to make sure that the back-end wiring is not your barrier. Does that make sense? All right. Monash is a university in Australia. There's a friend of mine who runs a network out there. They have a pharmacology department. I think they're number 2 in the world-ish. So it's a massive data capture analysis job. So they have a bunch of very expensive machines. Like one of them produces a 500 gigabyte image every time they run the test. So they were transferring this across their normal enterprise network, i.e. it's a gig. Machine runs test, transfer 500 gigabyte, run test. So basically what you're finding is the network is becoming the barrier to efficiency and productivity. Now, as I said, they're running this across the standard enterprise network because they're not funded to actually upgrade the network. But then you say, hang on a second, what did the machine cost? But you know how this works. They can get the money for the machine, the network is owned by someone else. All right, so basically they went and bought the N-base-T, added up 3BG, 2.5 and 5 gig stuff. All right, so this is actually a NIC. You can go buy this on Amazon for about $130. It also looks very cool. So they went and got some Cisco switches and ASUS NICs, and they get 5 to 10 gig over the same wiring. Data goes 4 to 5 times faster, they get new work. This is actually the speed test, so getting 2.3 gig down and 7.4 up. So you must have some people in your enterprise that have a similar problem, whether it be pharmaceutical, scientific research, CAD/CAM, all these other guys. You find the people who need more bandwidth and say, I can now go help you. Because from my point of view, my job is to make sure you guys can say yes more often. Okay. Going to talk resort hotels versus cruise ships. And I put this slide together because I was going to talk to people who do cabling in buildings. I want to have something funny to talk about. So as it turned out, the Cisco guy I was talking with does cruise ships for a living. So I decided I would compare them. So this is the Encore in Vegas, right? Anyone been to Vegas? Yes, seen the Encore? Anyone stayed there? So when they built it, 2008, 2,000 rooms, 45 floors, 44.5 million square feet. So think about this. This is if you take that building and you put it on the side and you sailed it out to sea, it would look sort of like this. But of course, you wouldn't have power or easy deliveries. This is the Regal Princess. Basically, it's from Carnival. 2014 was a cruise. So they support, there's about 2,000 cabins, right, for guests and 3,500 guests, but there's also the people who work on it. 19 decks, 141,000 tons. Almost the same thing, right? If you think about it, right, they've got to do the same job, but they don't get the luxury of having their people come to work every day. They don't get the luxury of having, the supply of stuff coming in. So think about, we know how to build networks for this, right? You thought about this one? Right. So the network on this is sort of like an enterprise, right? So this is our standard picture of an enterprise network, right? You must have all seen this, core, access distribution layer, access layer, stuff underneath it. Now, I see there is a presentation later on about rethinking this. That'll be fun to go look at. But this is the world I live in. So imagine you have this, and these guys, by the way, they're not on the enterprise network, they're also a local DC. So they have everything in that ship. So this is actually the floor plan of that ship. You can go and grab this stuff, take a look at this thing, right? You say, that's sort of fun. Recabling this is bad, but think about the ship. So a few things that you have to think about. Fire zones. Okay, you're in the middle of the ship, power, cooling, and airflow, pretty interesting. They're normally built offshore. In the Encore case, it's built in Vegas, you know what the rules are, right? But if the thing is built in Lithuania or somewhere else, the translation between what we want and what they do is quite different. But here's the key thing. These things have a 30-year design lifespan. Okay, so think back 30 years and think forward 30 years. So building a ship today, it's got to last 30 years. The infrastructure you put in for cabling must adapt, because imagine if you had to take it out. Okay, so this is some products from N-Based-T Alliance. Actually, this is N-Based-T products. The Alliance has both a member product list and also stuff we just see. And this one over here, this is very exciting when they released this. This is the Apple Imac Pro. Anyone seen one of these? So I think you can get up to about 64, 128 cores, a large amount of memory. So the interface at the back. So this is a content creator class device. Interface at the back is 1, 2.5 gig, and 5 and 10. If I'm doing media work on this, I want stuff. If I'm streaming stuff to it, I want it uncompressed. So this is the Lions camera I was telling you about before. This is fun, right? As I said, it's this big. Sits at the end of a conveyor belt, generates 4 gig uncompressed video. This one up here is a NAS you can buy. I just saw QNAP release another one. So you can go buy one of these, because it's pretty easy to get a NAS that would run more than a gig. And if you're in pro gaming, this is what Netgear recently released at CES, right? They released the cool looking switch. So when I first was talking about this technology in gaming, I thought it was inappropriate because it actually adds latency. As it turns out, the gaming guys just care about not ever dropping. So I have a guy who runs, they call it LAN parties. So he says this is great because they can build a network and then offer 5 to 10 gig access to the common service. So everything just runs better. So the product library is basically sitting up on N-Based-T.org. Go take a look at it. We add it we add things to it as often as we can. All right, some key interesting messages from N-Based-T. So I told you earlier, we're transitioning wireless being additive to the enterprise switch market, which for a guy who sells switches is awesome. What it means is we're providing good service and we're expanding the network. So this is from the other guy at 650. What we're seeing is now a lot more devices, and this could be like an Intel PC, it could be like a network storage device, it could be a camera. These things are doing connections at more than a gig. Right, the fact that basically we're going to have all people shipping pretty soon, and this is going to let you expand and adapt your campus to suit the business need. Threw this one in because this is from a friend of mine who's the chief editor of Cable Installation and Maintenance. CM is probably the biggest cabling magazine. And he's going to work with me because we're going to explain to the cabling guys, first base, how you should change how you do your work and how it's going to make your work more valuable. Because traditionally in the cabling world, what they would do is they would bundle up the cables really tightly because they thought that looked like good workmanship. As it turns out with Cat 5e and Cat 6, because they don't have resistance to alien crosstalk, that's actually bad. So you have to explain to them how you really want to change the way you do work to improve the performance. All right, so this was the old .3 rule, right? 10 times the speed for 3 times the cost. Well, this is an awesome rule. This is why we went from 10 meg to 100 meg to a gig to 10 gig, right? All good things have to come to an end. So I went to look at this. The actual term for this is speciation. And looking over this side, right, if you think about how development works out, you branch off to all the big stuff at the edge and then you fill in the middle. So that's what we're seeing a lot of, because we're now seeing 2.5 and 5 gig and 25 gig and 50s coming, because we're actually filling the words in the middle. at the start, right, we basically had the ability, every new speed has new cabling because every network is new. How often do you guys get to build new networks? Most of your work is upgrades, so now we're rethinking, we're basically focusing on value. So standard is active in 10 meg, 2.5 gig, 5 gig, 10 gig, 25, 50, 100, 200. 400 is just finished. So we actually have all these standards and speeds active at once. Okay. Bunch of work I've done is 25 gig outside the DC. Has anyone got 25 gig running inside their data center? A couple. Oh, Russ will have if he was awake. So, I'm glad I couldn't hear that. So, 25 gig started 2014-ish is when the standard started. And when they first started, the whole story was basically server to switch connection. And now optimizing around things like the what we can do with SerDes speeds and what PCI works. Now, when this standard started, they defined it as server to switch. So they did twin-ax and they did 100 meters of multi-mode. And it was very cool, but unfortunately for me, it had no value. I had to figure out a way to get 25 gig outside the DC. So these slides, I'm hijacking these slides from what was called the call for interest. So the way Untitled 3 works is we first have a meeting, and in Cisco terms, this would be a CC, and you ask the entire group, it's like, we'd like to start a project to do about this. If you get approval, then you move to what's called a study group, and then the study group finishes and defines some project documents, and then you get approval to move to a task force. So this is slides from the 25 gig single mode CFI, which I helped run. Like, what were we talking about, right? At the time, 25 gig was basically defined to be single lane, right? Twin-ax, base T, and multi-mode. I wanted this one to start with. I wanted single mode because I could take that outside the DC and I needed it at 10, 40 kilometers because that's what 10 gig runs. I actually needed a longer reach multi-mode, but we just finished the multi-mode standards. That wasn't the place I wanted to go into. And so this is an evolution story. I want to evolve from 10 to 25, first in the DC, then spreading out the SP in campus. So what's the status? The original standard that did the first couple got approved in 2016. We started a task force and we're trying to finish October 2017. Okay, so what are we talking about? So this was the picture for data center, right? Data center 25 gig was really focused on the server to switch connectivity. But when I took this out and I took it to the campus, I'm looking at access switch aggregation, maybe aggregation to core, and maybe a big handoff to the SP. So it was an access layer technology in data center becomes a generally used technology in the rest of the world. Is this making sense? Now, to do that, I had to figure out how to make sure it would run over what was running 10 gig today. If I go and give you a network that says, if you change both ends and put the optics in, it works, that's fine. If you have to go and recertify the optics or change the cabling, that's not so good. Okay, so this is the standard. We actually finished it. What's interesting here is this is the back page of all the IEEE standards that we do today, which is consensus we build it. So, as I said to you, individual vote with all your competitors, suppliers, and customers in the room, you got 75% of people agreeing. Like, what would it take to get 75% of this room agreeing on anything? So, the work I do a lot about is trying to explain what you guys need, because if I can explain that story, I can take all these people with me. If I start an argument about technicalities of how to encode bits, I'm lost. So this standard we started in 2015, we finished in 17. So I have this thing now, I really like to do short standards, but these are more packaging than the new technology, right? It's productizing stuff we know how to build. All right. You get the point? Who remembers when 10 megabits was the standard rate? People after my own heart. We're doing it again. 3 megabit was getting a bit weird, right? That was ArcNet probably. And if you like ArcNet, you should go talk to Russ later on. So here's the thing. If you talk about industrial networking, this is one example. What you're seeing is in the middle of the network, it's all moved to Ethernet. But on the outside, there's a bunch of other stuff, right? And the general name for this is field buses. So what you're seeing is there'll be a whole Ethernet network. Then there'll be some sort of gateway converter box that'll run field bus on some sort of serial protocol and talk to a sensor. The problem is both these gateways and sensors, there's 1,000 different protocols, and it's all very low level. That's not a way to evolve. The way I tend to think about this is in the older times, you might get an alarm from a device, and you send some guy out there, he'd basically hit it with a hammer and listen to it. Those people are moving out of the business. If you get someone who's hired today, he wants to basically go in there and log into it. It's like, what do I do now? Well, these devices don't support a web server. How do I upgrade those devices? So we're looking at this gap at the edge. Why 10 megabits and long reach? So we went and took a look at the field buses, and what it turns out is if you hit like a kilometre and 10 megabits, you've basically got most of the market. So that was our starting point. Now we could have targeted 12 megabits, etc., but 10 megabits is the existing Ethernet speed. So I can just say, I don't have to change those speeds, I just have to create a new physical layer. All right, and this is probably the best place to see, the sorts of things we're looking at is Profibus and HART and LAN Open and DeviceNet and Modbus and there's other people, right? They're using every type of communication under the sun. And I want to get rid of most of these things. Actually, I want to evolve them to Ethernet because it's just simpler to make work. All right, why single twisted pair? Cable reuse. In reality, basically, if I can, rewiring a building is bad, rewiring an industrial plant is a disaster. Okay, so here's the idea. It's a field bus upgrade, right? So this was the market potential numbers from July 16. We've got the project running. They're thinking about 55 million a year for industrial automation, maybe 10 for building, 100 million for automotive. I actually think these numbers are very conservative. How do we make this consumable? We use over the install base cabling. We support the cabling topologies, which includes multi-drop. Yes, we're actually going to go and build 10 megabit Ethernet multi-drop again. It's going to be CSMACD because that's what's defined, and a single cable for data and power. So the standard is up and running. It's called CG, single pair Ethernet. You can go find about it. So CSMACD is back. We're going to do multi-drop and power over 25 to 50 meters. Okay, here's an example. Anyone know who CHI-NOG are? Okay, founded in 1910. Headquarters in Espoo near Helsinki. 52,000 people. They're the fourth largest manufacturer of elevators and escalators worldwide. What's interesting is they also do maintenance and modernisation. An elevator is the oldest robot most of us have dealt with. Okay, so what do CHI-NOG think about themselves? So this is from their homepage in Australia. They improve the flow of urban life. They're thinking about how to move people around. They're not thinking about how to build an elevator. The question is how to move people more efficiently. So if I take a look at what's on their mind, again, this is pulled from Australia because there's slides there. They're saying, again, this is an elevator company. So Australia's a single DMBN, it's the broadband network, and they're saying, how do you migrate? Right? What does it mean for building owners and managers? Okay, so elevators are cloud connected today. Right? They're cloud connected and they talk in real time today. And they want to basically be able to do service updates on the go from a mobile. It's like, hang on a second, they look like a technology company. So ignore the fact that they build elevators, they're a technology company and they want to basically optimize their technology for the people in the building. Here's the network structure. So this is an elevator, and I actually have these slides from CHI-NOG because I'm working with these guys. They tend to build them in, I think, about 8 floor chunks, because that's a nice chunk. And it's a layered architecture, right? So you end up with having you've got user owned sensors, your elevator and motion controls, there's a bunch of group control, site control supervision, and cloud backhaul. They build networks. But inside most buildings, there are multiple of these networks for the elevators and everything else, independent of what we see. If you think about where hacks come from these days, we want these guys under control. What do they need? Here's their requirements. They need edge compute, functional safety, voice and video streaming, power of the network, software upgrade, cybersecurity. They need all the stuff that we've built. So if we do this properly, we get the ability to bring these guys on and leverage everything we learned. Okay, so single pair Ethernet, it's basically going to be a driver. In these guys, this is CHI-NOG slides, elevators and escalators, all of the OT control plane in your building or your factory. So just for the elevator market, there's about 20 million nodes a year. They reckon they can get to half of them. Okay, so I'm going to close up. Anyone read Don Quixote? So Don Quixote is actually one of the oldest works of literature in the Spanish language. And if you remember the story, there was Don Quixote and his trusty servant, Pedro. And he was going around Spain trying to fix injustices. Now, he was a good guy, but his vision wasn't so great. And so he went off and for some reason decided this windmill was actually a giant. So we have this thing called tilting at windmills. And so in my world, this is me and this is the single pair Ethernet. So I'm going to go and try and construct a single pair Ethernet ecosystem that matches the one we succeeded for 4-pair base T. So if I have to do that, I have to figure out how to follow that story, which means I need power and data, I need structured cabling, and I need standard connectors. Because I need to make it consumable. Okay, so here's my wrap up. This is the same bolt, right? Great runner. He's the fastest person in the world. If you imagine he's actually running 10 Gbc, he needs category 6A, right, to work best. Awesome story. There you go, put him on ice. So if you have this value incident, what you want to do is evolve the business, the network enable the business, and that's what Embase Alliance does, and that's what really drives me. So I'm done. This is the first edition of Don Quixote from 1605. And so thank you for being on my journey with windmills.